Morning class. 4.3 Trigonometric Ratios, Part 1. So a little bit of review on primary trig ratios. Sine ratio. Okay, when we have our right triangle trigonometry, sine ratio, sine of theta, is the ratio the opposite to the hypotenuse, opposite side to the hypotenuse, given an angle theta. Cosine adjacent over the hypotenuse, and tangent is the opposite over adjacent side. And you can remember these ratios using the acronym SOHCAHTOA. Okay, in this course, we're going to learn the reciprocal trig ratio. So exactly as it says, reciprocal, we have what's called a cosecant ratio, abbreviated CSC, of theta. Is the inverse or the reciprocal of, is the reciprocal of the sine ratio. The secant ratio, which is SEC theta, is the reciprocal of the cosine ratio. And the cotangent ratio is the reciprocal of the tangent ratio. We can remember the reciprocal from each primary trig ratio by the fact that each pair has only one co-prefix in it. So cosecant goes with sine, secant goes with cosine, and cotangent goes with tangent. Okay? In the six ratios, now you have six ratios to remember. The argument of the expression, that is, theta is the argument of the expression, that is the value for which we are finding a ratio. Okay. Couple more things. Review. For an angle theta in standard position as shown below, complete the following trig ratios in terms of x, y, and r. Okay. So sine of theta is y over r. Cosine of theta is x over r. So if I'm labeling this, folks, this is opposite, adjacent, this is hypotenuse, right? So I'm just replacing x's, y's, and r's here. Okay, tangent ratio is opposite over adjacent, y over x. Cosecant ratio is the reciprocal of the sine ratio, so it's just r over y. Secant ratio is the reciprocal of the cosine ratio. So secant of theta is r over x, and cotangent of theta is the reciprocal of the tangent ratio. So we have x over y. Okay, remember the cast rule? This is super important when we're thinking about trig ratios in the various quadrants. Now we are dealing with negative values as well. Remember in grade 10 math, we only dealt with positive trig values. Now we can have negative. So cast rule tells you which ratio is positive in which quadrant. So CAST, cosine ratio, is always positive in quadrant 4. All ratios positive in quadrant 1. Sine ratio is positive in quadrant 2. Tangent ratio is positive in quadrant 3. So what this means is that if the sine ratio is positive in quadrant 2, then the cosine and the tangent ratio are negative in quadrant 2, and likewise for the other quadrants as well. Okay, the reciprocal ratios follow the same framework as their corresponding primary ratio. So cosine ratio, positive in quadrant 4, so the secant ratio is also positive. All ratios positive. Sine ratio positive in quadrant 2. That means the cosecant ratio is positive in quadrant 2. And if the tangent ratio is positive in quadrant 3, then the cotangent ratio is the positive in quadrant 3. Okay, so that's cast rule. A little bit more review, next page. Okay, reference angle. A reference angle theta r is the angle formed between the terminal arm and the x-axis. The reference angle must be an acute angle, that is between greater than 0 and less than 90, or greater than 0 and less than pi over 2 radians. Determine the reference angle for the following angles in standard position. So This is something that's handy to memorize, or you do this enough, you will know it right away, right? So you practice enough, you don't need to actually memorize this. It'll become one with your memory. Okay, determine the reference angle for the following angles in standard position. So I'm going to draw this out. So 45 degrees. Well, in quadrant 1, theta equals theta r. So my reference angle, theta r, is 45 degrees. Okay. Number 2, or letter B, I have 2 pi over 3. So pi over 3 is about here. 2 pi over 3 is right here. Okay, 2 pi over 3. Okay, in quadrant 2, so I know my angle's in quadrant 2. The reference angle is right here. What is this reference angle? Theta r. That's my reference angle. Theta r equals pi minus theta. Okay, so that's pi minus 2 pi over 3, or 3 pi over 3 minus 2 pi over 3, and that equals pi over 3. So theta r here is pi over 3 radians. Letter C, 7 pi over 6. So if I'm counting, that is pi over 6 more than pi. So I'm going to go all the way here. Pi over 6. That's theta equals 7 pi over 6. What is this reference angle, theta r? Theta r this time is pi plus theta r is theta minus 180 degrees. So not 180, pi, because we're in radians. Okay, so that is 7 pi over 6, and I'm going to rewrite pi as 6 pi over 6. So my reference angle is pi over 6. Okay, letter D, 327 degrees. Well, that's all the way, that's 33 degrees shy of a full rotation, so right about here. So it's all the way like this, and that's theta equals 327 degrees. In quadrant 4, what is theta r? Theta r equals 360 minus theta, which is 327 degrees. So theta r equals 33 degrees. Okay, you should memorize the trig ratio formulas, the cast rule, and the reference angle rules. Very important when we do this. It needs to, at this point in 30-1, it needs to be fluent. Okay, quadrantal angles. Write the values of the primary ratios for each quadrantal angle. So sine of 0, that's opposite, which is 0 over adjacent, opposite over hypotenuse. 0 over 1, well, that is 0. Cosine of 0, that is adjacent over hypotenuse. Well, at 0, it's 1. Adjacent side is 1 over 1, and that's 1. Tangent of 0, that ratio is adjacent over hypotenuse. Opposite over adjacent. Tangent of 0 is the opposite over adjacent side, the ratio. Or we can think of it as the sine ratio over the cosine ratio, which in this case is 0 over 1. And so the tangent of 0 is 0. Sine of 90, when we get to 90 degrees, sine of 90 opposite over hypotenuse, that's 1 over 1, that's 1. Cosine of 90, that is adjacent, which is now 0 over hypotenuse 1, that's 0. tangent of 90, if we do sine over the cosine, that's 1 over 0. Well, this is undefined. 180. So if we look at the values for the primary trig ratios at an angle of 0, well, sine ratio, likewise, at 180 is still going to be 0. Cosine, instead of 1, now it's on the negative x side, so it's going to be negative 1. And then the tangent is still 0 because of the sine over the cosine ratio. Likewise, for our last quadrantal angle at 270, if sine of 90 is 1, then sine of 270 on the other side, it's the negative y value, it's negative 1. Cosine of 90 is 0, then cosine of 270 is still 0. And then tangent, the sine over the cosine ratio, it's still undefined. Okay, coordinates in terms of primary trig ratios. If P of theta equals xy is the point on the terminal arm of angle theta that intersects the unit circle, then cosine of theta equals x over 1 equals x, which is the first coordinate. So this is why the unit circle is super handy. Sine of theta equals y over 1 equals y, which is the second coordinate of P of theta, which is the y value. So P of theta on the unit circle is just xy. Okay, so you can describe any point on P of theta on the unit circle as cosine of theta, sine of theta. So very handy, it's your xy values on the unit circle. Next page. Okay, you can also write the tangent and cotangent ratios as a quotient of two other trig ratios. We went over this already, right? The tangent ratio is the sine over the cosine ratio. Cotangent ratio is just the reciprocal of this. Okay. Note also another way to think of tangent of theta, y over x, is actually the slope of the terminal arm. Okay. Here's a handy chart. Here's the unit circle. Okay, example 1. In which quadrant is tangent of theta less than 0? So CAST, right? Cast rule. Tangent of theta is less than 0 in quadrant 2 and quadrant 4. Okay, and cosecant of theta, I'm going to think of cosecant of theta. I'm going to check sine of theta. That's the way I remember. Where's sine of theta greater than 0? This is in quadrant 1 and quadrant 2. Therefore, cosecant of theta is greater than 0 also in quadrant 1 and quadrant 2, because these are reciprocal identities here. Okay? So where do they match? Where is tangent of theta less than 0 and cosecant of theta greater than 0? Well, only in quadrant 2. So only in quadrant 2, where tangent of theta is less than 0 and cosecant of theta is greater than 0. Okay, determine the exact values of trig ratios given a coordinate point. The point, negative 1/3, 2 square root of 2 over 3, lies at the intersection of the unit circle and terminal arm of an angle theta in standard position. Sketch the diagram to model the situation. So if I have my unit circle here, folks, let's draw that in. And somewhere over here on the unit circle, I have negative 1/3, 2 square root of 2 over 3. Here's theta. Okay? If I look at this as a triangle, I have r equals 1. That's a unit circle. My y value, 2 square root of 2 over 3, is the height of my triangle. And then negative 1/3 is the base of my triangle. Okay, so sketch a diagram to model the situation. Okay, so let's prove that it's actually a unit circle here. So if I do this, right, I square the first term, and I add it to the square of the second term, what will I get? That is 8/9 plus 1/9 equals r squared. That's 9 over 9 equals r squared. That's 1 equals r. Well, that checks. And that makes sense because it's the unit circle. Determine the values of the 6 trig ratios for theta. Okay, let's do that. So I'm going to use this triangle right here. And note that I'm keeping that as a negative because that will matter when we're doing our ratio because we're in quadrant 2. Okay, so I will just redraw this, folks, here. Okay, so sine of theta equals y over r, and that's 2 squared root of 2 over 3 over 1. Well, that's just 2 squared root of 2 over 3. Cosine of theta equals x over r. That's negative 1/3 over 1, adjacent over hypotenuse, so it's just negative 1/3. Tangent of theta equals y over x, or sine over cosine. So I'm going to do this, 2 squared root of 2 over 3 divided by negative 1/3. Okay, let's do a little bit of math here. That's 2 squared root of 2 over 3 times negative 3 over 1. And that is negative 2 squared root of 2. Okay, for my reciprocal trig ratios, cosecant of theta equals r over y, or 3 over 2 squared root of 2. So I'm taking the reciprocal. When I rationalize, let's rationalize our denominator. I get 3 square root of 2 over 4. Okay. Secant of theta, which is the reciprocal of the cosine of theta, that's r over x, and that's negative 3 over 1, or just negative 3. Cotangent of theta, that's x over y, or you can think of it as cosine over the sine ratio. That's negative 1/3 over, oh, let's make it easier. I'm going to take this and just take the reciprocal. It says 1 over negative 2 squared root of 2. Let's rationalize. That's square root of 2 over negative 2 times 2. And that's square root of 2 over negative. That equals negative square root of 2 over 4. Okay, example 3. The point D, negative 5, negative 12, lies on the terminal arm of an angle of theta in standard position. Determine the exact value of each trig ratio for theta. So let's be careful here. So when I draw this out, folks, negative 5, negative 12, negative 5, negative 12. Okay, so out here somewhere, okay, let me draw my triangle in. That's negative 5, negative 12. There's theta. There's my right angle. Okay, so I can find the hypotenuse. I know it's a Pythagorean triplet. I know it's going to be 13, but let's just do it here. Negative 5 squared plus negative 12 squared equals r squared. That's 25 plus 144 equals r squared. 169 equals r squared. 13 equals r. So r equals 13. Okay, now that we have all three sides, let's do all our trig ratios. Sine of theta equals y over r. That's negative 12, opposite, over hypotenuse. Cosine of theta equals x over r. and that's adjacent over hypotenuse, negative 5 over 13. Tangent of theta equals y over x, or sine over the cosine ratio. That is negative 12 over negative 5. That equals 12 over 5. Okay, keep them as exact values, no decimals, folks. Okay, let's do this reciprocal ratio. So for the reciprocal of sine of theta, that's cosecant of theta, that's r over y, and that's just negative 13 over 12. So I'm taking the reciprocal of the sine ratio. For the cosine ratio, secant of theta, that is r over x, so I'm going to go negative 13 over 5, which is the reciprocal of that ratio. And then the cotangent ratio, which is the reciprocal of the tangent ratio, instead of 12 over 5, I'm going to take the reciprocal, that's 5 over 12. Okay, last one here. Determine the approximate value of trig ratios given an angle. Justify the sign of each answer. Okay, sine of 1.92. Okay, so we need to be in radian mode for this one, right? So I don't see a degree, so this is radian mode. Okay, so sine of 1.92 equals 0.9396, so a little bit of calculator work. We would expect this to be positive in quadrant 2. So if you go a theta value of 1.92 radians, it's going to end up somewhere in quadrant 2. Okay, and when you calculate that ratio in radian mode, it's 0.9396, so this is positive in quadrant 2. Okay, tangent of negative 500. Well, let's take a look at this. Okay, negative 500, I'm going clockwise, right? So one revolution, and then 140 degrees more, I'm going to end up in quadrant 3. Okay, so theta equals negative 500. Well, what do we expect for a tangent ratio in quadrant 3? Well, it should be positive. So when I evaluate this on the calculator in degree mode, this is degrees, folks. You got to swap back and forth, okay? Be ready for that. 0.8391. And so this is positive in quadrant 3. Secant of 85.4. I'm going to look at 1 over the cosine of 85.4 degrees. And when I look at where that takes me, it's right about here. .4 degrees. Okay, these two statements are equivalent because I'm taking the reciprocal of that ratio. So this value ends up being 12.4690, which is a positive value, which is what we expect for quadrant 1 for a cosine or a secant ratio. Cotangent of 3, 1 over a tangent of 3, I get negative 7.0153. Notice that there's no cotangent button on your calculator. You have to do this, right? And remember, this is radians. Don't forget radians. When I draw this out, 3 radians is all the way out here, folks. Okay? Should be a 3. And we notice that this is negative in quadrant 2 because we expect the tangent ratio and therefore the cotangent ratio to be negative in quadrant 2.